Hi, and welcome to another interview for the Zero to ASIC course. And this week, I'm very pleased to be joined by Dinesh. Dinesh has been taping out on MPW 2, 3, 4, and is planning to go for 5. And he's got a very interesting project called Riscduino. It's one of the best documented projects I've seen, and he's bringing a lot of design and layout experience. So I thought it'd be a really good idea to have a chat with him, find out about his project, and see what his plans are going forwards. So, hi Dinesh, how are you doing?
I'm doing good.
Good. Yeah. So, could you tell us about a little bit about yourself and your experience?
So I'm in with this fairly settlement for more than 20 plus year. I worked in Cypress Semiconductor for 5 year, and then I worked in 8 year in Centillium and Bar Transuch. And next 5 year I was worked as an independent technical consultant. And last 5 year I'm working in Intel India. So during my career I had a lot of chance to work with the different aspect of SOC designs such as architecture, RTL implementation, SOC integration, verification, synthesis, M-based scan, timing closure, and silicon bring ups. And I also had a chance to work with the tester team to do a silicon debugs. I'm also a so good software developer where I write good C, C++ embedded software also. Overall experience wise, I have some limited experience around the analog implementation and some physical design checks. And over my associates, I worked in different foundries like a TSMC, Global Foundries, UMC, SMIC, and technology from 180 nanometer, 130 nanometer, all the way to 22 nanometer. I had a working SoC chips, which I worked around these 20 years.
So, how have you found enough time to get involved with the open source tools?
From last 10 years, I normally am one of the contributor in the opencore.org. I used to add some of the IPs in the opencore.org, and I normally a regular contributor in IP contributor there. But open tools is something I started from last 1 year, I can say.
And maybe you can tell us a bit about the aim of Riscduino.
So I also a lot of played around with this Arduino, and as we know, this Arduino is one of the popular embedded platforms used across the globe because of its openness in the source and hardware and software, and it's ready to use. And a lot of examples are there around these Arduino projects, and also there is a huge community base to develop a lot of applications are there. The current aim when I started, its aim is to not to reinvent this all these application and try to use this Arduino examples applications and try to add additional value by increasing customization supports, because once you have an base bone, so user can add new modules there. If you see Arduinos, normally it is built with multiple add-on cards. So user can instead of adding add-on card, once they have a backbone of this Arduino pin compatible setup, they can play around and add those IPs within the same SoC, so that they can get a much better customization of the chip.
So, are you planning for your chip to be a pin compatible replacement to the common Atmel 328 in the Arduino boards?
Yes, the whatever the currently the plan, we the total pin wise we have additional pin because whatever Caravelle setup has a 38 pin. What I made sure that the first 20, the 28 pin functionalities are exactly matching with the Arduino board. So there will be some board rework, but at least the pin compatibility on those things are exactly try to matched.
Okay. And obviously, it's a RISC 5 core instead of the AVR core that was originally in the Arduino
Yes.
product.
So that's what the aim is to create inside the Arduino firm software, add an additional board like a Riscduino and create a GCC compiler for this 32 bits RISC core so that it looks transparent. So they just select a board as a Riscduino and current application automatically will be targeted to the current 32-bit RISC core with corresponding firmware changes, because my UART and USB drivers may be different. So we need to change the base driver according to that board, so that it looks transparent. The same sample code should be able to run in this board, this ICE chip also. That is the aim.
And will you be also doing the software side of things so that it can work with the Arduino
Yes, I
libraries?
have some knowledge on around that. I'm just started playing around those things with the application part, where to plug in there.
S-
So
Sounds like a big job. Sounds like
yes,
a big
yes.
job.
So I am looking for a lot of community help also here.
Okay. Yeah. Yeah. Actually, I had that down at the end about anything else you want to tell us, but now maybe it's a good time if you want to tell us what kind of people you're looking for to help you with this project.
So one of the things, I have very limited knowledge on this unlock implementation. So I need some unlock implementation helps to add on this additional hooks which is missing in currently my project. And also I want to improvise further on the verification sides. That is the one more place where I'm looking.
Okay.
And third one I can see is the embedded software, because the way I built is I wanted to even run the Unix in this setup. So I may added additional cache, data cache, all these things. My intention is to all the way to boot this system to Linux. So I'm looking for people who can help me to import the Linux to this Riscvi.
Linux on Riscduino.
Yes, Riscduino, I
Cool.
wanted to port it. And also I'm looking for people who can help me in integrating this Arduino software. So where I can add a plugin if someone has already some knowledge on adding the board and how to add this GCC compiler trained integrating and updating the individual drivers. So I'm looking for all these places, community help. Otherwise, it may go in slow pace, I can see.
Yeah, so let's just jump now to my question about analog stuff, because one of the things I was interested in is with the Arduino, you've got digital ins and outs, but you've also got some analog stuff like A to Ds and D to As. Are you implementing them at the moment, or is that currently unimplemented, and that's why you're looking for people to help you on the analog side?
Yes, currently I'm not implemented ADC DAC and those unlock part. It's just a placeholder. I try to use the current some of the Caravelle projects where they used, but I don't see it not completely fitting with my requirement. Where I was looking for a six ADC, six channel ADC, and it is doesn't fit there. So I'm looking for some help there.
Okay. Now, one thing that I was interested in when I was looking through the projects is you've actually been on um, MPW 2, 3, and 4, and you're going to be going for MPW 5 as well. Is that correct?
Yes.
Yeah. So, what's been the differences that you've made in between each of your applications?
So the first version, if you say it's just a base RISC-V core, which I taken out from the open core, and I'm able to compile it to the open source tools. I think that's nothing much change I done. And I added with not first version was not a RISC Arduino compatible pin. It's just to try to prove the RISC core works with along with the SDRAM controller. So that is the first version I tried in MPW2. And MPW3, I tried the first, I can say the Riscduino, where I am trying to uh, modified for with the pin compatible things, where it doesn't have a instruction cache and data cache. It's a basic Arduino, but it will not able to boot all the way to Linux, because it doesn't have any internal cache. So it will work like a standard Arduino. That's what my current understanding. I'm thinking in MPW3. And in MPW3, non-risk also I tried, like a MBIS controller. One more project I tried is MBIS controller, where I targeted 1 KB, 2 KB SRAMs with row redundancy support. It is a non-risk based shuttle I
What's
tried.
a sorry? What's I didn't get what that was. An MRISC controller.
MBIS controller, which typically
MBIS.
around the memory. we add a controller. If there is a fault inside the SRAM, it can check. It will have an automatic test to validate all the SRAM functions. And if it fails, when I say when we have a redundancy, it can if there is a row failure, if there is one particular address is failing, it the function has a four failures can correct it itself, so user will be transparent. So there will be a four location addition will be kept inside the RAM. Those will become as a replacement. So this is like an error correction type. If there is a four failure, location failure, and user will not notice. So that I tried
Okay.
in MPW3. And MPW4 I tried with the first time with a cache, this whatever same risk core with Arduino, where I integrated iCache in instruction cache and data cache there along with the SRAM there. So it is some little bit increment and also cleaned up some of the verification I can see. In the same MBW4, I tried one more non-RISC-V based project, that is a logic based. So the MBIST and logic based difference is the MBIST only validate the SRAM part, where logic based is like a scan. It is like an on-chip scan to validate all the logic what you implemented is actually manufactured correctly, which is one of the critical thing for an SoC to make sure that whatever the manufacturability of the things are taken care correctly. So for that, for the single domain thing, I made my own method and added a logic based which on power on automatically sends us patterns to validate all the flops and the combination logic to see if there is any failure. If there is no failure, it will match with the golden signature. So that is the one I tried. It's in MPW4. In MPW5, currently what I'm trying is a two RISC-V based project. One with single RISC-V core, where I done some upgrade in Wishbone, where previous Wishbones are just a interconnect, which means if there are three masters are there, only one access will be passed through, even though there is a cross between them going to the other end user. Still, it will wait until the previous transaction is completed. But in MPW5 onward, it is a crossbar. That means if the processor is fetching a SPI access and parallelly data path is accessing some other block, it can go parallelly. It's like a crossbar. So that is added, which my feeling it will improve the performance to when you want to try to boot it to Linux. So it is going to help there. And in MPW5 itself, the one more project I added is a dual core, the same as the previous one, but here the data is there is a two RISC core is integrated. I wanted to see how this multi-core function is going to work. So effectively, except the MPW2, nearly I tried and two tape-ins, tape-outs, I can say, and five are targeted to RISC-V based, and two are non-RISC-V based. Around seven tape-ins, if we
Okay.
include MPW5.
Taking advantage of the Google sponsored shuttle.
Yes,
Good. Yeah.
yes,
So one of the things that I really liked about your project, and I'm checking it again now, is the documentation, which is very got great coverage on the project. And you also have a good framework for doing the verification. So I was wondering if you could tell us a little bit more about the verification that you do.
yes. I try to see because this RISC-V core has its own a lot of compliance test, which industry to check all the instructions are as per the RISC-V standard and interrupts. There are already standard defined tests are there. I ported all those tests here so that so it is not broken with the integration with the SOC and reading from the external flash and accessing the things. I nearly ported all the RISC-V cores. I think it itself is more than I think 100 test cases are there comes along with this compliance test. I'm integrated all of them, and I even integrated the core mark and dry stone compliance test, which directly checks the performance of the RISC-V. That also ported here just to check it is not broken those vectors there. And some of the critical IPs like a RISC-V core and Quad SPA has their own block level test cases because they are the critical block in this project. I have a separate test bench, standalone test bench, Git repo there. I'm very validating in depth in RTL also and also in the gate level, just to see after synthesis it is not broken. So in at SOC level, you can say most of the recipe course I brought it back to SOC level, and I made sure that at least one test is there for each IP, each interfaces. And the standard approach I done is 90% of the test I'm running at user project level. Means I'm directly driving at the wishbone level so that it runs runtime is faster. And 10% of the test I'm run with along with the Caravelle so that nothing is broken when we integrate with the Caravelle.
Good idea. Another thing I noticed when I was looking through your repository was that you've also got quite in-depth timing analysis. Is that something that you can spend a bit of time telling us about?
Sure. If you see the total Riscduino project, there is a lot of interblock communication is there. So because of that, the IO constraint becomes very important aspect in this timing closure. Otherwise, the SOC is going to break if you're not cleanly constrain the interfaces. So for that, that I typically use the standard industry standard procedure where we allocate around 40% for each inside delay across each IP. That means one IP will have a 40% inside delay, other IP will have a 40% inside delay, and 20% is used for the routing, so interconnect. So the I constrained all the interfaces with that SDC constraint, and first level we I synthesized based on that. Then at SOC level, I plug in both the netlist and SPEF along with the SDC constraint just to check the is it constraint is good enough and the timings are met. If there is a failure because of the interface, one IP is taking more delay than the other one. I cross check whether other IP has enough block has enough margin. Then I will readjust the SDC. Or if I need to tighten those SDC, then once again I retighten the SDC constraint and go back to the in the individual IP and resynthesize and try and get back once again and feed back to the main timing closure and check is it fits or not. So it's a iterative process I can say. But I try to create a full SOC setup where I cross check individual IP timing uh, at SOC level.
Yes, I think there's okay support in OpenLane for saying, okay, I need this clock frequency or whatever, and then being able to get the reports back on setup and hold timing and so on.
Yes.
But one of the things that was interesting, that I thought was very interesting with your design, is because you've got all these separate blocks and there's all the timing constraints in between the blocks. So is that something that you had to do yourself, or was that supported already by the tools?
Typically, we need to add from our end because then whatever is there in the open line is a general constraint. So here we need to, and since my design has a multiple clock domain, I need to create my own SDC, and I need to define with respect to which clock these IO constraints are defined. So if you go and check, each IP block has its own SDC with exhaustive definition of each independent IO constraints with input delay and output delay. And I played around along with my top level timings and to meet full SOC. So it's I can say it's the base is there from the open lane for a single clock domain for type of design. But the way I implemented is a multi clock domain SOC, which is something which is different, I can say.
Okay, so my last question for you is, given all your experience with the kind of industry standard tools and working with these large companies, what's your opinion about the open source OpenLane ASIC flow?
I can say it's something which is a great start and effort and initiatives. I can say it's a huge effort to bring so many tools and bringing a working case itself is a huge huge initiatives and efforts. I can think it's a great. But what one of the things I think over the MPW to MP5, I see the flows are getting continuously getting changed, and keeping track of that, it is becoming a itself is like an one more additional work. So we are not spending more time on implementing a design. We are trying to track the tools change. So I think that should be reduced. At least the changes should be in the very low levels, so that user doesn't notice it, so that whatever knowledge we gain in each MPW does not lose. So the incremental effort, I think, something people has to take some time and decide things. And also, if it is possible, they should give a backward compatibility. Like typically there is a version, so typically they we can people can suggest put it in config.tgle, seeing that automatic the tool takes that version and automatically converts those commands into the new version, so that it looks transparent. So those type of things, I think it's people should try, so that people dependency on these changes can be reduced. And some of the current seeing the industry tools and OpenLane tools, what one of the things I see is the utilization still is running in very bad numbers. Like just I see 30%, 40% type of utilization in normal designs, and if it is a complex design, I see less than 30% utilization. I see it's need a very there is a good scope to improve that, to bring it to 60%, which will give at least give some ballpark compare with the commercial one. And one more thing what I see is LEs is not up yet, which is very much a critical task in SOC, where RTL logic equivalent test is broken. It is not seen as a one of the check in this flow, which is very much critical check, because I myself seen so many time why is netlist optimizing the designs because of some syntax completely. Until you run a gate level simulation, you will not notice it. So I'm worried this LEC is broken, can create some issue for the complex designs, and you may see some surprises there. And one more thing around voices in netlist generation also, I have some concern, in the sense if when you see the netlist, it is like an increment that flops are is like a numbers, not like a cell names. If you not typically, if you use an industry tool, the names of the cell flops exactly match with what is there in the RTL. So easy to debug if you are running something in netlist or timing closure. It is easy to tell which block the timing is violated, so that you can go and debug that. You can go and modify the RTL to improve the timing. But whatever voice is netlist, it is tough to debug, I can say. They should preserve the cell name matching with the RTL. Otherwise, going forward, I find industry people will see it's tough to use it use for a complex design. And the last one I can see is one more thing I can see is the scan. I don't see much progress on the scan.
Do you mean like JTAG, scan chain insertion?
Scan insertions, I see not much progress happened. If we are wanted to productionize the chip, then the scan is a very much basic requirement which is missing, I can see. And other things, some of the things I see is in the physical design flow, there are placement, whatever pin placement, there that is automated. There is no way a user can control the each bit's positions. So because of that, there are big routes are happening between the each IPs, so there is no way I can control the pin positions. So which is a very much a basic requirement in complex design, where one common IP is talking to multiple sub IPs. So that will give a scattered routings. I done my own way of some hacks and try to make made straight routings. So if open route,
Doesn't pin order.cfg control the order of the pins?
that's what it controls, the order of the pin. It doesn't control the location of the pin.
Okay.
So because of that, if we have a one IP which is a very large, which is vertically large, and there
Hmm.
are so many small IPs sitting next to the parallel, like a wishbone interconnect. When you see it, it is a one vertical block talking to multiple IPs. So because of this continuous scattered placement, the positions will come in a bulge fashion, doesn't come in a straight route. If there was a control to say which location I want this pin, then it would have happened at direct routes. I see that is the one of the things missing. I can see that is typically it will be available in the other standard tools where I can get a direct interconnect between the IPs, which is one of the required, I can say, with the complex SoC design. And one more thing I see is the clock latency. See, when a design having a multiple IPs with a same clock domain, you need to match the latency, clock latency. So one IP may having a 8 nanosecond latency, other may have a 4 nanosecond latency. By concept, typically one round we run some synthesis and find out what is the which block has the highest number of latency, then give a constraint to the rest of the synthesis script saying constrain this block with this latency, so that it becomes easy for timing closure. Currently that IC is a manually we need to adjust the latency between the each IP to get a clean timing closure.
Okay, so thanks very much for your time, Dinesh. Is there anything else that you want to mention?
Yes, the only thing I can mention is I'm looking for a community help because it's a big project, and it has a lot of opportunity for the people to learn in both in verification, embedded, and also they can contribute in so many things. I can see people who are interested, they can contact me through the Slack.
Okay, so the best way to contact you is on the Skywater Slack, and your handle there is Dinesh. Okay, great. Well, thanks again for your time, Dinesh. Really good to talk to you, and I'll see you around on the Slack.
Sure.
And I'm looking forward to
Thanks.
seeing
Thanks.
what happens when you get your MPW2 chips back.